How's it going, everybody? Today we'll discuss the problem integer to Roman numerals. This is a commonly asked question in companies like Apple, Google, Microsoft, and Amazon. Today we'll look over what the problem is, discuss what Roman numerals are, and then finally solve this problem with C++. So the question is pretty self-explanatory here. Only thing you need to take a look at is the constraint. So Roman numerals are only ranged from 1 to 3999. This is because of the number of letters that are given in Roman numerals and only how far you can go with it. So keep this in mind when you're solving this. Now let's look at what Roman numerals are. Roman numerals are divided in two sorts of numbers. First is ones and other is fives. In ones, you're given the letters I, X, C, and M. And they have the value associated with in ones, which is increasing in unit places. So I is going to be 1, then X is going to be 10, C is going to be 100, and M is going to be 1000. So you can see how it increases in unit places. Same goes with the second part, which is fives. Here you're given the letters V, L, and D. So V is 5, L is 50, and D is 500. And you can see they're also going in unit places fashion. So how you would make numbers in Roman numerals is by using something called additive and subtractive property. Basically what you'll do is, so if you want to make a number 1, you just take the letter I and that's your answer. Now if you want to make 3 is same as taking 1 3 times. So 1 plus 1 plus 1 would be 3, and therefore you can take I, which would make 3. Now if you're given a number like 11, to make 11, you're going to take the number 10, and then you're going to take the number 1. So keep in mind that you're first taking the largest number possible, and then you're going to do the same again. So if you're given a number like 1000, you don't want to take 1000 i's. You take M first, and then you take the second largest number, and that's how you make the numbers. So let's look at some examples here. So here, if you're given number 3, I'll just take I 3 times because there is no other bigger number than 1. So if I'm given a number 170 here, I'm first going to look at the number 100, which I can make by taking C. And then I'm left with 70, so I'm going to use 50, which is L. And then I have 20 more, so I'm going to take 2 X's. So the final answer will be CLXX. Now let's look at the last one, 651. To make 651, I'm going to take 500, and then 100, and then for 50, I'm going to take L, and then for 1, I'm just going to take an I. So my answer would be DCLI. Okay, so what you saw until now was using the additive property, and where all you did was just add the numbers whenever you put letters into it. There's another property called subtractive property. So for numbers like 4s and 9s, instead of using 4 i's for 4, what you'll do is you'll take 5 and then you subtract 1 from it. So in our current case, what we do is whenever you put a letter, you put the letter 1 after the current one. In subtractive, if you want to subtract the number from the current one, you put the letter before it. So for 4, you're going to take 5 and then you put 1 before 5. So your 4 is going to be IV. Same goes for 9. So instead of taking V and then 4 i's, you're going to take X and then you're going to put an I before it. So a 9 is going to be IX. And this trend follows as the unit place gets bigger and bigger. And so for a 400, you're going to take a 500 and then you're going to subtract 100 from it. So 400 would be CD. And for a number like 190, you're going to take C like you would normally take it. And then you're going to add a 90 to it. So to add a 90, you're going to take XC, which is 100 minus 10. So your 190 becomes CXC. Alright, so this is the basics of Roman numerals. Now here, keep in mind that you're constrained by 3999. There is additional techniques to go beyond this limit. We're not going to cover them right now because that's not the part of this problem. But if you want to learn more about it, stick to the end and we're going to cover that in more detail. So let's look at how we're going to approach this problem to solve it. So let's say we're given the number 456 and I want to solve this and get the Roman numerals for this. To solve this, we're going to use a technique called dynamic programming, where we're going to divide this into multiple subproblems, and as we solve one by one, we're going to get the final answer. So The way to do it one by one would be taking one digit at a time, and then we get the Roman numeral for each one, and then we're going to combine it to form our final Roman numeral. So to take number 6 by itself, what we're going to do is we're going to mod the number by 10, and then we're going to convert it into Roman numeral, which is going to give us VI, and then we're going to divide the number, the original number, by 10 to get rid of 6. Now, as we move unit places, our number gets larger, so we cannot use the same V and I's anymore. We're going to have to up the numbers by 1. So now for the second place, we're going to use the letters X and L. And so now we're going to mod our number again to get 5. And then we're going to convert that into Roman numeral. So now we're going to use the letter L for 50. And let's add that in our solution. And then we're going to divide our number by 10. So we get rid of 5. The remaining is 4. Let's move our Roman numerals one place more. So now we're going to use C and D. Okay, so for 4, our Roman numerals is going to be CD. And so we're going to add CD into our solution. And then we're going to divide our number by 10. And we don't have any numbers left anymore. So our final solution is CDLVI. Okay, let's go ahead and see how this is going to work in code. So here we're taking the function called int2Roman. And inside of this, we're given an integer called numbers. So we're going to define a string called Roman, which we're going to return at the end of our function. So inside of this, let's take account for a constraint. If the number is 4000 or beyond or less than 0, we're going to just return an empty string. Then let's define two arrays. One is for ones and other is for fives. These are going to hold our Roman letters so we can use them at the end. Notice that here we're defining them in the order of unit places. So I is going to be 1, X is 10, C is 100, and M is 1000. So it's in the increasing order. Then we're going to define this variable called unit place. This is going to help us keep track of where we are in these arrays of 1s and 5s whenever we're going through this number. So we're going to loop through this number until it's greater than 0. Instead of this, we're going to take the mod of the number to get the digit that we're going to convert into Roman number. So once we got that I, we're going to divide our number by 10. And then here we're going to convert the number by Roman. We'll get to this in a bit. And once we're done with that, we're going to increase our unit place. So let's look at the 1s, 2s, and 3s. So in that case, we're going to take the unit place value in the 1s array. And so if let's say if it's the value is 1 itself, and our unit place is going to be 0, so we're going to return something like an I. But if our unit place is in the thousands, you want to return an M. That's what this is going to do. And in that string, after we attach our current number, we're going to attach that string back again. So we're always adding in front of the string, not at the back. This is because we're always going one place up, not downwards. Okay, so to take account for 4, what we're doing is we're taking the 5's value and then we're putting the 1's value ahead of it. Our 5 value is pretty simple. We just take the 5's value, which is the same as the 1's value. So for 6, 7, and 8, it's going to be pretty self-explanatory, so that we're just taking a 5 value and then we're adding the necessary amount of 1's value. For 9 here, what we're going to do is we're going to take the 1's value from the place after the current one. So let's say we are on the single digit value, but we want to take the value of 10, not 1. So we're going to add 1 to our unit place there to take the next one's value, and then we're going to add the current one before it. So for our 9's value here, what we're going to do is we're going to take the 1's value from the next unit place, and then we're going to put the current 1's value before it. So let's say if the value is 9 itself, and you're in a single digit numbers, so your unit place is going to add 1 to it, so it's going to take 10, and then it's going to put 1 ahead of it, so that makes it 9. And you're going to add that in front of the current Roman string. Make sure when you're doing this 9, you're doing else if and just not else. Otherwise, it's going to do this also for 0, which we're not doing anything here for 0. If your number is just 0, there's no value for that in Roman numerals, so you just ignore that. And there you go. This is the final answer. So now let's look at what the complexity of our solution is. So you're going through each of the digit in our number. And so as it scales up, you're also going to go through it more times. But this thing scales linearly. So our runtime complexity would be O of n. For our space complexity, it's going to also scale linearly. So our space complexity here is also O of n. So with the current method we saw, you can only do numbers up to 3999. And to put it into Roman numeral, it will look like this: MMMCMXCIX. To basically go beyond it, there is no way than using these two techniques. Let me show you what these two techniques means. So in the first one, what we're doing is using I, and then we're putting C's around it. So if you put a C on both sides of I, that's going to account for 1,000. And if you put one more C, so two C's around it, this is going to count as 10,000. And if you're only putting one C, that's going to be 500. If you put two C's, that's going to take it to 5,000. And if you just put three C's on the right side and nothing on the left, that's going to be 50,000. So this is basically you're just putting C's around I, and that's its own letter. And then you can put the rest of the letters like you would normally do. So if you want to make a number like 50,001, you're just going to put I, C, 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 and then you're going to put one more I after it, which is going to account for that one. Now, let's look at the second technique. In this one, what you're doing is you're putting a line on top of the letters, or two lines around it, or you're putting three lines, two next to it and one on the top. And these are basically like multipliers. So if you put it on top, you're multiplying it by 1,000. If you put lines next to it, you're just multiplying it by 100. And if you put it together, you're multiplying it by 100,000. So X with a line on top of it, instead of being 10, now becomes 10,000. M with lines next to it would become 100,000 instead of just 1,000. And then I with all three lines, instead of one, would become 100,000.